Hello, my name is Lani Lehman, and I'm recording this video for COM 3210 Big Data for the second assignment. I have opened the folder that I would be submitting. First, I will go through each file. First, we have the input files over here in .txt. Then we have the documentation in the PDF file. And this main file is the main source code file that we would run. We will open it in Visual Studio. It's a IPYNB Jupyter Notebook file. This is the other .py file that the main would be using to run the algorithms. And these two files are the only files that you would require for the running of all the source code, the main and the R-tree function. And they would produce two TXT files. One is query results, and the other is time comparison. The last one is the video link, which will have the link for the video this video that I will be uploading. So now moving on to the main file on Visual Studio. So first, what I have done is that I'm importing the files over here, and I've defined the input files here. Then I'm initializing the list for points and queries. And then I test if the data was read correctly. Then we move on to the sequential scan. We start the timer over here, and then we end that over here. We've defined our logic for querying here. Basically, what it does is that it goes through each of the data points. And then it tells the number of data points in the query. Points in query range sequential.scan. It appends it in the end. The number of points in the query range that comes out, and then we output the total processing time for the sequential scan and the average for each query. Then we move on to the construction of the R-tree. For the construction of the R-tree, we have all the functions defined in this .py file, R-tree function. We basically have two classes over here, the node class, and it has its functions, the way that it handles the overflow, checks if it's a root, check if it's a node. And we also have the R-tree class, and then also we have defined the functions like split and how the overflow is supposed to handle. And these are all the functions that would be required for running the file in the main IPYNB file. And then we output the construction overall time for the construction of the R-tree. And then we do a comparison of all the total times of running these queries, like using a sequential scan and the average processing times. We've output it over here. Lastly, we move on to the construction of the R-tree using the design, the divide and conquer. The code uses a divide and conquer strategy with an R-tree data structure to process queries efficiently on a set of points, X and Y. What we do is that it divides the points into two groups based on their X coordinates using a midpoint that we have defined over here. Two R-trees are constructed for the divided point sets. During querying, the code determines if a query falls entirely on the left-hand side of the midpoint or crosses it. We have defined that over here. And it queries the appropriate R-tree then accordingly and combines the results. The code measures the time for the R-tree construction and querying, providing insights into the performance. We have outputted that over here. And then finally, we output the queries into another file. We have that as queries underscore results.txt. So what it does is that it runs every query defined in the 200 query range. We can see that it has 200 as the index. And the results are supposed to be the same. It says that all of these three methods are efficient in their own ways. The sequential scan would be the slowest, and then R-tree, and then R-tree divide and conquer. And then lastly, what we do is that we compare and output the results of the three methods, the average processing time, the total processing times, and we do a comparison, and we output this result into a TXT file called time_comparison.txt. And here is the result for that. Thank you. That will be all from my side. Hope you liked the presentation. Thank you.